Okay, guys, we're going to kind of transition here. So we just talked about equations. Now we're going to talk about inequalities. So an inequality, if you actually look at the word, it says equal in there. So it's going to be kind of similar to equations with some things, but it's unequal. So we're going to actually be comparing expressions. So that definition there, a mathematical sentence that compares expressions. So you've seen these symbols before, so they're not brand new to you, but we're going to kind of use them a little bit differently. The most important thing, I think, if you're going to take away anything, is that inequalities have many solutions. They actually have infinitely many solutions. So, like when we solved our equations, we got one answer. Like we got x equals 2. Okay, that's one solution that's going to work. Now, in inequality, you're going to have infinitely many. So, you're going to have many numbers or values that are going to work for the inequality. So, we'll kind of talk about what that means. It's going to be important here in a second. So you can see on the screen here, you've got that table of your 4 symbols. So I would make sure you have those written down, and those phrases that are in that table are important also. So I would maybe just copy down that table or parts of it, just so you kind of have it as reference. Okay, so we see this is our less than symbol, our greater than. These two are just a little bit different because they have that line underneath. Well, that's going to mean, okay, this is less than or equal to. So whatever value we have, that could also be equal to that value. So same thing over here is greater than or equal to. Okay, and then you kind of have some common phrases there. Those aren't the only phrases you'll see that associate with those symbols, but we'll kind of talk about that as we go. Okay, now when we see an inequality, we always read the variable first. We've still got variables in there. We're not always going to see on the left. So we're used to reading from left to right. It's tricky with the inequality signs. You always want to look at the variable and read that first and then go in that direction. So like these two examples, we have x is greater than -5, okay, just like we would normally read. But this example over here, we've got the variable on the right side. You just have to be careful because if we just look at the symbol itself, we see greater than, but we're talking about the relationship of these two numbers and the variable, to the value. So I would read this backwards, actually. If I were to read it out loud, I would say a is less than 2. Okay, so see how I kind of read that backwards? So that, remember that alligator mouth opens towards the bigger value. So that means in this case, a is the smaller value. So that's really important to not get tripped up there. Again, like I said, inequalities have many solutions. So like if I tell you x is greater than -5, and I said, give me a number that makes this inequality a true statement. You guys could all give me a different value and it would work, okay, as long as it is true. So like you could probably think of 10 examples in your head right off the bat. What's a number bigger than -5? Well, 0. So x could be 0. X could be 1. X could be 3. X could be 15. We could go on forever. Those are all values that are bigger than -5. Okay, so these are only 4 examples of literally infinite numbers. Okay, so understanding that idea is super important. So same thing over here. Now remember, a is less than 2. So what could a equal? It could equal 0. It could equal -10. It could equal -40. It could equal -1,200. It could equal -1,000,000. Okay, those are all smaller than 2, so they would all work. So understanding that it's a set of numbers. It's not just one number. A solution to an inequality is tons and tons of numbers, infinitely many. Okay, so it's going to be important when we come to the graphing. We're going to do a couple examples of writing inequalities from words. Okay, so that table up there might help you here. So if I have a number p is fewer than 7. Well, the two things I'm going to have on either side is p, that's that number, the variable we don't know. And then we're comparing it to 7. We just got to figure out, okay, that is fewer than, that's where our symbol's going to go. Well, p is fewer than, it means it's smaller, so that's going to be less than 7. So p is less than 7. Okay, pretty straightforward. Next one, a number w minus 3 is no more than 10. Okay, so let's tackle this first side here. So a number w minus 3. So w minus 3. Okay, so we're comparing it to 10. It is no more than. So if you think in your head, like think about if I told you you can have no more than 10 cookies. Okay, well, that means you can have 10 cookies, right? But can you have 11 cookies? No. Can you have 10 and a half cookies? No. But you can have 10. Can you have 9 cookies? Yes. 8 cookies? Yes. So it can be smaller than 10. So that means this has to be smaller than, but remember we said it could be 10. So it's less than or equal to And there's your inequality. Okay, that's all you got to do there. Okay, so why don't you guys go ahead and try this last one? So try number 3 on your own and see if you can write that. So a number z divided by 2 is at least -6. So start with that left side. So the is at least is our symbol. We'll tackle that in a second. Z divided by 2. So I've got z. Now remember, division, we use our fraction bar. So show it with a fraction bar. That's z divided by 2. Is at least -6. So at least, if I tell you you need to be at least 10 years old to go on this ride at Six Flags, or it's like you have to be at least 4 feet tall. That means you can be 4 feet tall, but you can't be any smaller than that. So you have to be 4 feet tall or bigger. So at least means that's the smallest. So it can be equal to this value, or it has to be bigger. So it can be equal to, but or it has to also be bigger. So greater than or equal to -6 would be your symbol there. Okay. So just kind of referencing that, understanding those symbols. So the next important part here is graphing an inequality. So when we graph an inequality, this is where you're going to see how there's multiple solutions. Okay, so the most important thing is that open versus closed circle. Now, that doesn't make sense to you guys right now, but you're going to put a point. So we're going to graph on a number line. You're going to put a point at the value that you see on the number line, and it's either going to be open or it's going to be filled in. Okay, so it's super important that you understand the difference here. So an open circle, so I would write this down, change this font. An open circle is when that value is not included. So value is not a solution. So that means, let's look at number 2. This is an example. If x is greater than -1, can x be equal to -1? No, it cannot. So that would be an open circle when we use. So the symbols that we use there is our less than or greater than symbols. That's when we have our open circle. So that means then a closed circle, sorry, this is very annoying. A closed circle is going to be when the value is a solution. So it is technically going to make that statement true. So if we look at number 1, x is less than or equal to 3. Is 3 going to make that a true statement? If x was 3, is that less than or equal to 3? Yes. So we would use a closed circle when we graph this. Okay, so that's going to be our symbols that have the equal to underneath is when we use our closed circle. Okay, so let's take a look at what that actually means. So if x is less than or equal to 3, okay, well, I'm going to plot just a few numbers. I'm going to put a few numbers here on the number line. Well, I definitely need to have 3. And then I'm just going to put a couple more, 4, 5, and then 2. Okay. Remember, evenly spaced out here, and they have to go up by the same amount each time. Now, yours doesn't have to look exactly like mine, but you need to have at least 3 on there. So x is less than or equal to, first thing you have to look at is it an open or a closed circle? Well, we already said this is less than or equal to 3, so it's going to be a closed circle. So I'm going to put a closed circle right on 3. So I'm putting the dot right on 3. And then it's everything less than 3. So that means everything, which direction? Are we going to go to the left on the number line or to the right? It's going to be to the left because all of our numbers to the left are less than 3. So I'm just going to actually go a little bit above the number line and then draw my arrow. Notice how I put an arrow there because it's going to go on forever. Okay, it's all of those numbers after 3, below 3. Okay, so number 2, same idea, x is greater than -1. So I'm going to at least include -1 on my number line. I'm just going to include a couple more numbers. Look at that. That's all I need. So now when I graph it, x is greater than, am I going to have an open or a closed circle? Well, -1 is not a solution because it's not going to make this true. So I'm going to put an open circle at -1. And it's greater than, so everything bigger than -1. And again, you always put that arrow on there. And I go above the number line so that I can easily see when you guys are doing this by hand. Sometimes it's hard to go over and be able to see which direction it's going. So put it a little bit above, just like I'm doing. Okay, so go ahead and try this last one your own. This number 3, go ahead and graph that. Okay, so again, make sure you have 9 on there because that's going to be your point. Now remember when I said read this with your variable first. So the variable's flipped. So even though we look at the symbol, this is a less than or equal to symbol. However, since the x is on the right side, we're kind of reading it backwards. So x is greater than or equal to 9. Right away, you should have known that that's a closed circle. So regardless, you should have a closed circle at 9. But your arrow should be going to the right because it's greater than 9. Okay, so the trickiest part is that open or closed circle, and then just be careful if your inequality is flipped with the variable on the other side when you're graphing.